Okay, let's talk about the types of the assignment. The most important type, the type we build up to, is pile of cards, but I'd like to start with the simplest types and work up to it. And the simplest type is just a card itself, which is a struct, which contains two fields. I've already written it here as a red box, a value and a suit, and I've drawn those as little subparts of the red box. And real cards, of course, contain a value, 2, and a suit, clubs, or a value 8, and a suit, diamonds. There's no reason, of course, that we couldn't have stored more information for a card. We could have, for example, stored the back of the card. I mentioned that in lectures, I think, that sometimes different decks of cards have different backs. So if you were going to run a new deck more than one time, you might end up with red cards and blue cards. You might want to keep track of that in the type. What other things might you want to store for a card? Well, I guess a physical card could be a bit damaged, so you could store down here the condition the card's in. What else might you want to store? I don't know, all sorts of information that physically helped you describe a card. The idea is that this red box here, the card type, contains all the physical information you need to know to describe a single card. Now, one thing you might have thought we were going to store for a card is you might have thought we were going to store a value, a suit, and a pointer. I'll draw a pointer because the card is a red box. I'll draw the pointer as a red arrow. You might have thought you were going to store a pointer, and then we could use that to store a pointer to another card, which itself contains a pointer, which we could use to point to another card. And the last one could say store the null pointer. And this would then give us what looks like a list of cards. And you might have thought that that would be a sensible way of storing a list of cards. But no, we're not actually going to do that in this assignment for a number of reasons. That's not a very good way of storing a pile of cards. What are the reasons for that? Several. Let me give you some. The one that I probably am the most convinced by myself is a pointer from a card to a card to let us create a pile of cards. That's not a property of a card. There's nothing about a card that has a pointer to another card. The pointer really records the relationship between adjacent cards, the fact, for example, that the 2's on top of the 8, which isn't a property of 2, this card here, this physical card. It's a property of how I've arranged them. So it's sort of like a property that is a larger thing than the card itself. Now, to store information about relationships between cards in an entity called card is a bit weird, because it means that whenever I move the 2 around, I have to actually change the card record itself. It's like the card 2, this card physically changes when I move it around. And that's not how we think about cards, and we should make our program and the types we model in the program behave as closely as we can to the real world, to the actual things we're modelling, just because then our intuition is more reliable, and that will help us more when we're debugging or designing things. So I don't think our intuition supports the idea that a card would change as you move the card around, and similarly I'd like our types to be the same. Another reason that we're not storing cards in this way is a list directly with a third field pointing to another card, and each card pointing to another card, and so on, is if this was a list of cards, a pile of cards, then it would be quite difficult to insert new people at the top of the pile of cards, because you would store this guy here as being the top of the pile, and that would contain enough information to extract the rest of the pile. But then if you wanted to insert a new card at the top, well, you've already got a card that you're holding which represents the top. So you've got problems, actually. You can't really insert something up here if you're holding this as the top of the thing, and I guess you could go back to where you're holding it and change everything, but that's confusing. That's not going to let us then do things like add card to a pile, because as we add this card to the pile, and if we were going to add it to the top of the pile, this would change the top. This here now is no longer going to be pointed to the top of the pile. It's now going to be pointed to the second card down in the pile. So we'd actually have to change value, and we can't really change that value because this is only a copy of the pointer passed in, so it becomes a big ugly mess. So for that reason as well, and also the more compelling one for me, that cards themselves should model a card, we're not going to do it that way. Instead, we're going to have a slightly more elaborate structure. But don't worry, this elaborate structure in the end is going to be quite convenient and it is more powerful, let us do more things than we would otherwise be able to do. So the next level of complexity up is we now have a type called a node. And a node, like a card, is just a struct. It contains two fields. The first field, I'll draw it quite big here, contains a card. This is like a wrapper for a card. So let's just draw that again. So that could be the, for example, the 6 of diamonds. And the last field is a field called next, which is going to be of type link. Now what's link? Well, link is a pointer to a node. Let me draw a pointer as an arrow and I'll make the colours match. So a pointer to a node I'll draw as a blue arrow, and that is what we mean by a link. So next is going to be a link that points to another node. And that's going to let us set up a pile of cards as a chain of nodes. Okay, let's have a look at how we could create such a chain of nodes. It's going to look like this. We wanted to store the 8, then the 2. We'd store it like this. At the top, the first guy will be the 8. So that's a blue box, turning a red box. Like that. And this pointer is actually stored in here, and it points to the next guy, and that will be the 8 of diamonds, and the next guy is going to be the 2 of clubs. Okay, and our last next field will be null, which means we've reached the end of the list. So now this is giving us a very simple pile of 2 cards. It's a pair of chain nodes. But again, as I sort of indicated when we were talking about the possibility of having a linked list built out of cards, a linked list built out of nodes is still going to have the same property, that if we record the top node as being the list, that's what represents the list, it means we can never change the top node, and we're going to want to be able to do that. So instead, we could save a pointer to the top card and say that that was a pile of cards. But then again, we've still got the same problem that that pointer is going to have to change physically if we ever change a top card. And changing a pointer is quite hard if it's passed into a function. We can change what it points to, but we can't change the pointer itself because, of course, everything literally passed into a function is passed in as a copy, and so changing the pointer inside the function isn't going to change the pointer outside the function because it's just changing a copy of the pointer. So we have the same problem, that it's a bit harder to access the first element of the list. So for that reason, and also for 1 or 2 other reasons that I will talk about in a second, we introduce a third type, which I'm going to call a struct mypile. A struct mypile is a struct, another box. Again, it's only going to contain 2 things. There's no reason it couldn't contain more. The first thing it's going to store is something called a first. So I'm trying to draw this backwards, it's not working very well, a bit like Mr. Squiggle. And the second thing it's going to store is something called size.